won a scholarship to visit planets like Mars and the Moon. While he knew a lot about logarithms, but he thought that when he will go to space, he will have much more complex and bigger numbers to solve as logarithms. And so he wanted some tricks up his sleeve so that he can solve these numbers easily. So he went to Professor Magan so that he can help him solve these bigger numbers, or at least help him with some tricks which would help him solve these bigger numbers. So when he went to Mr. Magan, Professor Magan, what happened is that Professor Magan asked him to solve some very small numbers. Now, Sam was very confused that when he wants help with bigger numbers, why is Professor Magan asking him to solve very small numbers? But until he solves these questions, Professor Magan is not going to help him any further. Let's see what are the questions that he was asked to solve. So the first question was log of 1 to the base 10. Now, 1 is a really small number, but the base 10 is again a bigger number. So you have a bigger base and a smaller argument. So let's write it in the form of exponents. So we know that we need to find 10 to the power of what is equal to 1. Now from exponents, you know that if anything to the power of 0 is always 1. Whatever be the number, if the power is 0, the answer will always be 1. So what would be the power of 10 to get 1? Obviously, it will be 10 to the power of 0 is equal to 1. So it means that log of 1 to the base 10 will be nothing but 0. So if we write log of 1 to the base 10, it will be 0. So that was pretty simple. Now the next question. Here he was given log of 2 by 2 to the base 2. Well, 2 by 2 is nothing but 1, right? So you can write this as log of 1 to the base 2, isn't it? So let's see the same thing. So 2 raised to what is equal to 1? Again, anything raised to 0 is 1, right? So definitely for this also the power will be 0. That means log of 2 by 2 to the base 2 will be nothing but 0. Now the next question which he got is log of 1 to the base 3. Again, similarly, we can say that 3 can be raised to what power to get 1? Definitely 3 to the power of 0 will be 1. So it's very simple. So log of 1 to the base 3 is also 0. So now, after finding all these values, Sam found something similar in all of them. The similarity was that every time he was actually finding the log of 1 to different bases, and every time he got the answer as 0. So he clarified with Professor Magan if it meant something. Definitely it did. It was the first property of logarithm. It states that log of 1 to any base will always be 0. So that was the first property of logarithm, and it was pretty easy to find. But Sam was not convinced because he had asked for tricks to solve bigger numbers. How could this property help him solve bigger numbers? So Professor Magan gave him one more question. Now we have this particular question here, where we have log of 512398765 to the base 2 into log of 1 to the base 2. Now this number definitely Sam cannot solve, but Sam can definitely solve this part of the equation, which is log of 1 to the base 2, which is nothing but the first property of logarithm. So this will be 0. So anything multiplied with 0 will always be 0, right? So whatever big the number be, if you have log of 1, it will always give you 0, and the entire equation will always be 0. So definitely first property of logarithm helps in some way at least. Now, he got another set of questions. What were those? Well, the first was this. Here, log of 27 by 3 with the base 9. Now, if we solve 27 by 3, it is nothing but 9, right? So, when we say log of 27 by 3 to 9, it is nothing but log of 9 to the base 9. Now, again, if we solve it in exponential form, we have 9 to the power of what is equal to 9. Now, we know that any number to the power of number 1 is the number itself. So, definitely it is nothing but 9 to the power of 1 is equal to 9. So, here the exponent is 1, and that's what we solve in logarithms. So, log of 27 by 3 to the base 9 will be nothing but equal to 1. So, you saw that after solving this, he got the answer as 1. Now, what is the next question? The next question is log of 512 to the base 512. Again, we just apply what we have learned, that is 512 to the power of what is 512. Now, you see, anything raised to the power of 1 is the number itself. So, we can write log of 512 to the base 512 will be nothing but 1 again. What is the next question? It's again a simple one, that is 66 by 6. Now, 66 by 6 is nothing but log of 11 to the base 11. Again, 11 to the power of 1 will be 11. Therefore, we can write this as 1. So, again, we have 3 solutions. That is, for log of 27 by 3 to the base 9, we got 1. Log of 512 to the base 512, we got 1. And then log of 66 by 6 to the base 11 is again 1. So, we see that finally, all these equations have the same answer, the same exponent, and also every time we finally solve the same base and same argument. So, whenever the argument and base were same and the answer was always 1. So, was this also a property? Yes. This is the second property of logarithm. It states that if you have the base and the argument as same, the answer will always be 1. So, you don't need to solve such bigger numbers. You just need to check if the base and the argument are same, you will write the answer as 1. Now, he got another set of questions. This time he has some powers to solve. Now, here he has log of 6 to the power of 15 to the base 6. Again, we'll write this in exponential form. So, 6 to the power of what is 6 to the power of 15. Or you can write, let's assume 6 to the power of x is equal to 6 to the power of 15. Now, the base is same. That means x is nothing but 15. So, that means what? That means that this value is nothing but 15. Now, he has got another set of questions which will be solved very similarly. That is 12 to the power of x is equal to 12 to the power of 25. That means x is equal to 25. That means the answer for this is 25. Here we have log of 256 to the power of 512 with the base as 256. Again, a lot of big numbers, but we'll solve it in the same way. That is 256 to the power x is equal to 256 to the power 512. That means x is nothing but 512. So this will be what? This will be 512. So the solution for this is 512. So let's see at the three solutions. So we have a solution for this is 15, for this is 25, and for this is 512. Again, something very common. Every time the base and the argument are the same, except for the argument is raised to a power. And that power is the answer for this equation. So even here, the base and the argument are same, base and the argument are same, and the answer is their powers. So is that a property too? Yes. That's the third property. The third property states that if the base and the argument are the same, then whatever power the argument is raised to, that is the answer of such a logarithmic equation. And these are the three properties of logarithm. And if you know these three properties of logarithm, you can solve many complex questions very easily. Don't forget to subscribe to our channel. You can also register for free at DeltaStep.com to get all learning resources as per ICSE, CBSE, IB, Cambridge, or any other curriculum. Over 5,000 amazing lectures across maths, science, English, and social science. Our unique interactive video technology keeps you engaged, and our iDictionary feature allows you to quickly revise any concept. Master each topic at your own pace with our adaptive practice technology and 1 million plus questions. Get instant answers and detailed solutions. Be exam ready by taking unlimited mock tests, performance analysis along with actionable feedback, personal tutors to resolve your slightest of doubts. That's not all. You also get amazing prizes like PlayStations, iPads, watches, and many more, along with certificates through our Earn As You Learn program. So at DeltaStep.com, learning is not just fun and easy, it's rewarding too. So register for free now.